Before we proceed to the actual concerns on principle of inclusion and exclusion that involves prime numbers, we already talked about the fundamental theorem of arithmetic in the previous video. Let us try to also review this very important topic, the Sieve of Eratosthenes. This was actually developed by a Greek mathematician, Eratosthenes, in identifying the prime numbers. Let's just say less than 100. Sieve means there are some cancellations or removal that we need to do in order for us to identify the prime numbers really from 1 to 100 inclusive. So this is the process, or this process could also be your form of checking later on if you will be asked about how many prime numbers are there in less than 100. So you can actually use this as your checking as before we can look into a process involving the principle of inclusion and exclusion. So this is how it's done. Of course, we simply crash out the non-prime numbers. Let's start from the smallest one. Of course, 1 is not a prime number because we define prime number as factors 1 and itself. So obviously 1 is not a prime number for that. Let's proceed to 2. We know that 2 is a prime number. That's the smallest prime number. And if it is, we're going to remove all multiples of 2. Okay? By removing all multiples of 2, we can actually remove some composite, or all of them are actually composite numbers. We know that if we have a certain number n, and we can look for a prime factors of that, which can be expressed as p sub 1 m sub power of 1, p sub 2 m to the power of 2 until p sub k m to the power of k. That was presented in the previous video. We would know that if one factor of it is already a prime number, all of its multiples could be non-prime or composite. So for example, 20, its factor is 2 and 10. So basically 20 is no longer a prime number. Hence, in the Sieve of Eratosthenes, let's try to remove all those multiples of 2. So you have here 4, 6, 8, 10. And all of them in the same column here. So all of these are multiples of 2. That's why it's called Sieve of Eratosthenes. We are removing all of those which are not part of the answer. Okay, leaving 2 already as one of the prime number. Okay, how about 3? We know that 3 is a prime number. It's not a multiple of 2, so it stays as it is. Then with that, let us now remove all multiples of 3. Okay, because there are some multiples of 3 that were not removed here. 6 is already removed. We have here 9, 12, 15, 18, 21, 24, 27, 30, 33, 36, 39, 42, 45, and then 48, 51, 54, 57, 60. Okay? So simply try to remove all of them. Actually, this topic is also part of our number theory, if you can still remember. So you have 63, 66, 69, 72, 75, 78, 81, 84, 87, 90, 93, 96, 99. Okay? So that's already okay for 3. Next is 5 is not a multiple of 2 or 3. We would know this in that particular order because if there are numbers that were not cancelled previously by multiples of the previous prime numbers, automatically they are prime number. Okay? I'm talking about 5 and I'm talking about 7 here later, but let's start with 5. So 5 is a prime number. All of its multiples are non-prime. So all of the 10s here already removed. So this column by 5 also be removed. Proceeding now to the next prime number, 7 here. So obviously, we can see in this perspective that less than 10, there are 4 prime numbers less than 10. That's actually 2, 3, 5, and 7. So if you are asked with this, of course, this is very obvious, this is very small at this moment. But if you're asked about the number, you can just simply use this sieve or the item that we're going to present in the next few videos. So for 7, let's talk about 7. Multiples of 7, 7, 14, 21, 28, okay, 35, obviously they were all removed, 42, then 49 here, 49, then 56, 63, 70. 77, it could be removed, 84, 91, 98. Okay, that's it. So the first row indicates the prime numbers, again, less than or equal to 10. Let's proceed to the next row. we have observed that 11 is retained. So 11 is really a prime number. All of its multiples, 22, 33, 44, 55, 66, 77, 88, and 99 were also removed in this manner. By the way, you can even extend this grid. I just illustrated here to 100. You can even extend it to 200, 1000. But of course, it would take a lot of time and very taxing for some. So 11. Next here is 13. 13 is a prime number. Multiple of 13 is 26, 39, 52, 65, 78, 91, if I'm correct, 91. Yes, 91 can be divided by 13. Okay, and that's it. Now, the next prime number is 17. Obviously, as you go further, you can see actually that there are some numbers already removed because they were already multiples of the previous number, prime numbers. So 17. Next is 19. In short, for our n being 20, there are actually 8 prime numbers before less than or equal to 20. Okay, so 19, the next item for 19 is actually 38, already removed. 38 plus 19 is another number, 57, already removed. Plus 19 again, you will have 76, already removed. Plus 19 again, equal to 95, already removed, and that's okay. Now, next is 23. Okay, you can have here 29. I'm just going to list down all of them. 31, 37, 41, 43, 47. You can check mine if I have made a mistake here. 53, 59, 61, 67, and then you have your 71, 73, you have 79, 83, 89, and 97. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. There are 25 prime numbers less than, okay, or equal to 100. Even less than could do that. So the Sieve of Eratosthenes allows us to identify the prime numbers in this manner. Again, if you would like to continue, so on and so forth, you can also do that. Okay, I jumped it automatically because I can see that as long as we have a large number here, if we're going to multiply it or to 2 by its multiple, all of the 2's already removed because actually that's like you say, for example, 29, right? So 29 times 2, 58, that's already divisible by 2, so if I remove, when I do it again, so I can also see that there are also some of it which is removed because it's divisible by 3 as well. Okay, and if we're going to talk about 31, so the 62 is already removed, it's divisible by 2, and 62 plus 31, 93 was also removed earlier as it's divisible by 3. And even if you're going to look at the next one, 59, no need to multiply the 2 because it now exceeds 100. So this is very important as checking as to some items later on that will involve the concept of identifying number of prime numbers within a specific range. Thank you very much for watching.